Good day to you all. It's the last week of the school year. That's the last week of quarantine Algebra 2 lessons with Hotard. This is lesson 13, I believe. It's been going on for a while. Today we'll be working with arithmetic sequences. Before we get into that, just a quick update on life at the Hotard residence. The kids are driving us crazy, as always. Occasionally, Miss Hotard and I get to watch a little TV. We finished Stranger Things, and we've just started watching The Office. It's a whole cultural phenomenon we just totally skipped over here, and we're getting caught up. So far, so good. All right, now let's go ahead and get started with our algebra lesson today. Like I said earlier, we will be working with arithmetic sequences today. 3 things that you should be able to do by the end of this lesson. You should be able to look at a sequence, which is just a list of numbers, by the way. Look at a sequence and tell if that sequence is arithmetic or not, and then identify what's called the common difference. You should be able to identify a formula for that sequence. It's called an explicit formula, and then use that formula to find the nth term, the 20th term, the 30th term in the list. Now, a couple things about that. First of all, you might be wondering, why is he saying arithmetic? I thought the word is arithmetic. Arithmetic is a noun. Arithmetic is an adjective. It describes the type of sequences. A sequence is arithmetic if you're adding or subtracting the same value each time to get the next number. All right? We call that value the common difference. So if you look at number 1, -8, -5, -2, 1, what's the pattern here? It's adding what each time? It's adding 3. -8 plus 3 gives me -5. -5 plus 3 gives me -2. -2 plus 3 gives me 1. So I can continue that pattern. 1 plus 3, what would be the next number? It'd be 4. So yes, this is arithmetic because it's adding the same amount each time. The common difference, all right, that's the 3. We just abbreviate that as a D. D for common difference. D is 3. It's just what's being added each time. So number 2, all right, 35, 42, 49, 56. What's happening here? It's adding what each time? It's adding 7. So yes, this is arithmetic. The common difference is 7. Number 3. This one might be a little trickier for some people. It is adding something. It's adding what each time? It's adding -200 each time. So yes, this is another arithmetic sequence. The common difference, it's adding -200, or you could say it's subtracting 200. D is -200. And then one more. Right here, -2, 1, 6, 13. Let's see, -2 plus 3 gives me 1. I'm adding 3 here. 1 plus 5 would give me 6. Nope, not the same. So no, this one is not arithmetic. All right. Now, one quick question that some people have when I teach this lesson. They ask me, well, what if it's multiplying by the same amount each time instead of adding? Is that arithmetic? No, it's not. That would be geometric. We're going to talk about that later. All right, but to be an arithmetic sequence, you have to be able to add or subtract the same value each time. So this part, not hard. Pretty easy, breezy, beautiful, like CoverGirl. Okay, so before we get into the more complicated stuff, just take a moment, pause the video, look at that 8.2 Practice A page I did. I want you to just answer the first 4 problems, check your answers on my key, make sure you can do that, and then we'll actually get into finding the formula. Did you do it? Of course you did. So now, instead of just looking at a sequence and telling if it's arithmetic or not, that's easy. All right, let's actually figure out a formula, because if I gave you one of these sequences and I said, well, what is the 30th number in the formula, in the sequence right there, it would take you a while to go through and subtract 200 over and over and over and over again to get to the 30th term. There is a formula you can use to find this. I'm going to give that to you, but before we do, a little bit of notation. I want you to just write this down. All right, we already said, just so you understand what all the variables mean, we already said in all these problems that D stands for what? Common difference. D is the common difference. It's what you're adding and subtracting each time. All right, common difference. And then you're going to see this a lot in these formulas. You're going to see an A with a little 1, A1. I'm not talking about a steak sauce. A1 is just notation, it means the first term. The first term in the sequence. All right, so for example, in problem number 1, what was A1? it was negative 8. All right, D was 3, the common difference. All right, also, a lot of times you're going to see an N in these formulas that we're working with this week. N is the number of terms. So for example, if I was trying to find the 50th term, 50 would be N. I'm looking for the 50th number in the list. And then last thing, A with a little n, all right, that's the nth term, all right, and n is the number of terms, so basically you're looking for the last term. So if I'm trying to find the 30th term in a list, 30 would be n. What that 30th term is would be A of n. All right, so to give you the formula, before I write the formula down, just a quick thing, you don't have to write this down, but I'm just going to show you where the formula comes from. Let's just have an easy sequence. Let's say we had 3, 5, 7, 9, keep going on and on and on forever, and I wanted to write a formula for that. All right, first of all, what is A1? A1 is 3, it's first term. What's the pattern here? What's the common difference? It's adding 2. D is 2. So A1 is 3, D is 2. Now, let's say I didn't have the whole sequence. Let's say I just had this. I knew A1 is 3, D is 2, and I needed to know A2, the second term. All right, what would you do with A1 and D? You'd add them. That's the first term. You add them 2 each time, so you do 3 plus 2. That would tell you the answer is 5. All right, I know you could tell just looking at the problem that it was 5, but if you didn't know that. Now, if I needed to know A3, the third term, all right, again, if all I knew was A1 was 3 and D was 2, I'd start with 3, and I'd have to add 2 how many times? 2 times. So I'd be adding 2 plus another 2, or just 2 times 2. And that would give me 7. So same thing, if I needed to know the fourth term, I'd start with 3, and then how many 2s would I have to add? I have to add 3 2s. 1, 2, 3. 2 times 3, that would give me 9. So following that same logic, if I needed to know, let's say, the 20th term, instead of going through and adding 2 over and over and over again, I could just do 3 plus 2 times, now look at how many 2's we had to use. This one was just 2 times 1. All right, you notice the n, the subscript right here, it's not the same as these numbers, but it's very similar. These numbers that we're putting in the parentheses, what do they have to do with the n number? It's 1 less. It's 2 times this minus 1. So if this is a 20, this would be a 19. So I'd be doing 3 plus 2 times 19, which would give me 41. All right, so just to generalize that, to find a formula that'll work for any problem, not just this one, I'd say AN, all right, whatever the nth term, what was special about the 3 in this problem? It was what? It's A1, it's the first term, plus, now the 2, what was special about that? That was D, the common difference. It's going to be different every time. And then the number we put in parentheses, it's sort of N, but it's not N. It's N what? It's N minus 1. So it would be plus N minus 1, number of terms minus 1, times D, the common difference. That is my formula. So I want you to write that down in your notes. The explicit formula for arithmetic sequences, A of n equals A1 plus n minus 1 times D. This is the formula. We're going to be using it over and over and over again for the rest of the lesson. All right, so let's actually use that. So if you look at the next couple problems, I'm going to do 4 more. It asks us to find an explicit formula, find the formula, using that, what we just did, and then find the term name in the problem. It's asking for the 28th term. So in number 5, all right, I've got A1 right here. Here's 1. What's D in this problem? What's the pattern? It's subtracting 10. All right, so that means my formula, we'll find the 28th term in a minute, but let's write the formula first. A of n equals A1, which is 1, plus n minus 1 times D, which is negative 10. Now, this is the formula. I can simplify this, all right? If the problem were just asking you for the formula, this would not be the answer. I would need to simplify this. I could distribute this negative 10. I get A of n equals 1 plus, I'd have negative 10n, and then negative 1 times negative 10 would be positive 10. And then I can combine like terms. 1 plus 10 would give me 11. So my formula, A of n, would be negative 10n plus 11. That's the actual formula. And then, using that formula, I want to know the 28th term. What do you think I could do with that formula? I could just plug in 28 in place of n. To find the 28th term, I'm going to do negative 10 times 28 plus 11. All right, you might want your calculator for that. You might not need it though. Negative 10 times 28, negative 28 plus 11 is going to be negative 17. No, I'm lying. Negative 10 times 28 going to be negative 280. Sorry, negative 280 plus 11 is negative 269. Check it in your calculator if you're not sure. All right, and then number 6, same thing. Here's A1. What's the D this time? This time it's adding 10. All right, so positive 10. So my formula, AN equals A1, which is negative 28, plus n minus 1 times D, which is 10. Let's distribute our 10. AN equals, all right, and let's just go ahead and work this out. So negative 28 plus 10n minus 10. Combine your like terms, negative 28, negative 10, going to give you negative 38. So AN, the formula is going to be AN equals 10n minus 38. There's my formula. It's asking for the 23rd term. A23, going to be 10 times 23 minus 38. I'm going to use my calculator this time, since I'm doing this on the fly. 10 times 23 minus 38. There it is. 23rd term would be 192. All right, so it's just a matter of using that formula. 2 more quick problems, then we're done. Number 7. This one's a little different. This one's telling me A12 equals 2,211. That means the 12th term of the list is that. And then the 37th term is that. And it wants to know the common difference, the D. It's not asking for the whole formula right now. So, arithmetic, something that comes in handy, arithmetic is kind of like linear data when it was adding or subtracting each term. And then that common difference, that thing you're adding each time or subtracting each time, when we were working with linear equations, it's basically the same thing as the slope. All right, so I can use my slope formula in problems like this, because slope, usually we use M for slope. It's the same thing as D, the common difference. So if you remember that slope formula, M or D equals, you could subtract the y numbers on top, y2 minus y1 over x2 minus x1. The same formula works for arithmetic sequences. All right, so basically these n values, these are like your x values, and the actual numbers themselves are sort of your y values. So I can find my common difference using that slope formula. I can subtract these two, 7211 minus 2211 on top over 37 minus 12. And that will give me my common difference. So let's see. 7211 minus 2211 is going to be 5,000 over 37 minus 12, 35, 25. And then divide those. Let's see, 50 divided by 25 is 2. Then I have 2 zeros, so that'd be 200. Common difference is 200. So again, using that slope formula. So let's put it all together for this last problem. All right, this time similar problem. I know the 17th term, the 34th term, but this time instead of just finding a common difference, it wants me to find the rule. It's asking me to find the formula. So my answer is going to look like this. All right, well, I'll have to simplify it, but I need to know A1, I need to know N, I need to know D. All right, well, I don't need to know N, but I need to know A1 and I need to know D. So I don't know either one of those right now. So let's just start with D. Let's find our common difference just like the last problem. I'm going to subtract the two y numbers on top, 327 minus 174, over the x numbers, 34 minus 17. And I want my calculator for this one. 327 minus 174, going to be 153 over 34 minus 17 is 17. And 153 divided by 17 is 9. So that's my D. That's my common difference. That's not the answer, but I need that. All right, now I also need to know A1. So I don't know that right now. I could just keep subtracting 9 from 174 until I got back to A1. But there's a quicker way. I could use my formula. All right, this one right here, I'm just going to write the formula down. AN equals A1 plus N minus 1 times D. I know D. I just found that. And I could use really either one of these as AN. It doesn't really matter. All right, so I'm just going to pick one. I'm going to use the smaller one just to make life a little bit easier. I can use 174 as A of N. I don't know A1 plus N with 174. That was the 17th term, so that'd be plus 17 minus 1 times what was D? 9. And let's just work this out. Solve for A1 because I need to know that. So 17 minus 1, that's 16. 16 times 9 would give me 144. So I have 174 equals A1 plus 144. How do you get A1 by itself? You subtract 144. So and that's going to give me 30. There's my first term. So now I'm ready to write my formula. All right, A of N equals A1, which we just found was 30, plus N minus 1 times D. D was 9. All right, now I just have to simplify it. Distribute that 9. It'll be 30 plus 9N minus 9. Almost there. Combine like terms. Final answer, A of N equals 9N, 30 minus 9 plus 21. There's my formula. So y'all try the problems on that practice page. Again, email me if you have any questions. This is Hotard signing out.